So this is the key for my Smart ForTwo convertible, and like you can see, the button pads are broken, and I've already opened this up. This is some kind of rubbery material. It's stretched across these holes, and there were buttons on them which you can then press to open the car and open the roof and so forth. And now I need to fix this. You can buy replacement plastic casings or a whole new key, which you would then have to get programmed, which I wanted to avoid. So what I decided upon was to just make new buttons and then glue them in. To make room for the buttons, I just cut out, I've already done this now, cut out the rubbery material like this, but leave a small ridge here where I can apply the glue on. So that's how you prepare the key, and then you have to print all the buttons, and let's get back to you when I've done that. So this is a button in FreeCAD, and you can see it has, this is where the button holds. This is the clearance so that it can move up and down. You have the bottom side of the button, which actually actuate the electrical button on the circuit board. Then you have this little hole, which is just used to help with removal from the PI sheet. You can stick a screwdriver here and then sort of lift it off if it sticks very well. So there's not much that you really have to do in FreeCAD, but if you want to add your own logo, I found the SVG import and placement to be a little bit tedious, and I will show you how that basically works. So let's assume we want to put the lock on here, which is already available, but let's assume we want to do the same again, like emboss an SVG here. So I take the button, make a clone, and then import an SVG file, usually an Inkscape SVG file. That works fine. I import it. There we have it, not at the right location, but it's there. And I usually make the dimensions in FreeCAD pretty much exactly what I want here, so that I don't have to do any more scaling here. And this is a part that's a little tedious because you cannot just grab and place it. What you sort of have to do is to make these paths into sketch, and that you can use to emboss into this surface. So I would grab these ones, go to the draft workbench, and then use this button. That's the key here. That is draft objects to sketch. You get a sketch, which is an unconstrained sketch, but it's not a problem. Then you can remove the path objects or hide them away somewhere. Move the sketch into your new body, and then attach the sketch. I use map mode and then plane, and then this one. This will move the sketch onto the same plane as this face, but it's not positioned correctly yet. And this is also a little bit tedious part. I want to turn it so that the bottom half is in line here, which I do by turning the sketch here right away. It's 45, no, 45, minus 45, okay, that's correct. For some reason you cannot use the transform feature here. Oh, I'm doing something wrong. So Then I open the sketch, which gives you a lot of constraints here that are not really helpful in this case. But yeah, let's zoom in again. It gets a little bit slow. Then I select the whole sketch, all parts of it, just by left clicking and selecting it. And then this button is important. That lets you move, translate the whole sketch without defining any constraints. Just grab it and move it from some point to another point. And I want to I think this one here will pretty much be the center point. So I click here once and go there. Move it over, close it. Does it look good? Looks fine. And there you have it. Now you can go to the part design workbench again, where you have your sketch, which is sort of hidden here. And then emboss it as usually. Okay, this body is not active. Let's make it active. Emboss it. Tries to go through it all. .4 is correct here. Ah, yeah, that was kind of stupid. Everything is all right, but I'm overlaying with the blank button, hiding my edits. So there we have it, embossed as per usual. And yeah, that's took me a little bit to find the options to combine the path and then move them, but in the end it worked out quite well. Now you can grab the body and export it to STL and run it through your slicer. So for such a small print, I usually just use a little piece of filament so that the color change is not such a hassle. And with this one in particular, it's printed on the PI sheet, which you should normally not use for PETG. But I will do that here because the PETG attaches very well to this, which is good for such a small model and the small nozzle and the fine detail that is used. But I will do, once this is done and while it is still hot, I do not recommend this, but it's the way I do it. I just grab the sheet by the sides. It is hot, so maybe you want to wear gloves if you do something similar. But I will grab it and then take it to a sink where I have cold water running, and then run that water over the part, and it will sort of shock it, and then it releases way easier than if you have it cool down. For such a small model, the flex of the PI sheet will not help you to release it. It will just bend with it. It's very difficult to get off. And I also added a small feature in the print itself where I can stick in a screwdriver and help to lift it off. You will hopefully see that. Now I'm locating the feature for the screwdriver. Usually takes a little bit. Then it gets still wet, but I think this looks quite well indeed. All the fine detail, the movement. So okay, some blob here, but that's on the inside, that's not a problem. Yep. So here I have my buttons, which I printed out, which will get put into these positions. So these are just so that I can grab the button pads. Should work fine like this. Yeah. So that I can position them in the top. Okay. Now I need to apply the positions right. Need to apply glue to the ridges, and I think what will be best is to maybe use a syringe and just put an ever so tiny amount on there. I use CA glue, just regular CA glue. Let's see if this works. I think you can just use any wire or nail, you don't need to use a syringe. Or needle, not a syringe. Okay, I have some enough on there now. Now I grab my part, place it on there ever so carefully. Yeah, it's not going to be perfect. It's going to have a little bit of an individual touch to it. I think there's enough glue in there. I can actuate the button. Only needs a very small amount of flex. Now the open button. some pressure to the glue like this. Okay, I think we have it. Now let's have this cure for a bit. I don't want to spray a CAQ activator on this. I don't know how the rest of the plastic will react to it. Sometimes it gets very bright white or gray. So let's just wait a bit and see how this goes. So let's have a look how our little project turned out. I've given this about 2 hours to cure. It should not stick to there. Spilled a little bit of glue there, but does look good. Can all be actuated. Yeah, I think that's fine. And remove a little of the glue. Yeah, it's not a masterpiece, but I think it's came out quite nice. Would have loved to use the fluorescent filament, which I have a little bit of, but I doubt that I would have gotten that through the 0.25 millimeter nozzle, which is not hardened. And to my knowledge, these fluorescent filaments have little particles in them, which require a hardened nozzle and might even block such a small nozzle as a 0.25. So came out really nice and saved me maybe about 10 euro for actual new plastic cases, but now it has a unique look and feel, and that's invaluable.